All right, so this lesson is on evaluating limits without a calculator when you cannot just do direct substitution and you may not know exactly what the graph looks like without a graphing calculator, which you don't have access to. So let's talk about number one. I'm taking the limit. This is a rational expression, has a function in the numerator and a function in the denominator. Of course, I'm headed to a -3. Because that's where the denominator would be 0. If I was headed to any other number, I could just direct substitution, plug it in, get my answer, and be fine. But I'm headed to where this function has issues. So first thing I want to do is I want to know, is this an asymptote or a whole at -3? So to figure that out, I'm going to factor the top. Factors of 6 that subtract to give me 1 are 3 and 2. I want a +1, so I want a +3 and a -2. Now remember from what we said in 11.1, if what you have cancels, then is that a whole or an asymptote? Well, it makes that a whole. So I have a whole at x equals -3. I have an no, I don't. I don't have any asymptotes because the denominator would be completely gone. So because there's a whole at x equals -3, then the limit exists. The function does not exist. If I were to graph it, there would be an empty circle right there. If I were to graph it on my calculator and go to my table, it would say error when I got to x equals -3 because I cannot plug in a -3. But if I take the whole out, which is what you do when you factor and cancel, that's the removing of the whole. If I will then just reset my limit, and I want to see this part on your paper, I'm resetting my limit of my new function that has had the whole removed. Now I can just plug in a -3 and get where the limit is headed. Now, let's make sure we're crystal clear on this, and I'm going to spend more time on number one than I do on the others. But I am not saying that f of -3 equals -5. This is still f of x, and I cannot plug in a -3. But I know that at -3, the function, whatever it's doing, is headed towards a -5, but there is a hole there. So whatever this function may do, I know that as I fly in from the left or from the right, where x is a -3, my y value is headed towards a -5, even though this does not exist. Because remember, the limit as x approaches -3 of f of x does not equal f of -3. Sometimes it does, but that's not the definition of a limit. The limit is not where is it. The limit is where is it headed. Okay, so let's look at number 2. So if I look at my function, I see that he's going to have issues at 4, and of course, that's where we're headed with our limit. So I'm going to factor this. 12 that adds to give me 7, and I want a -7. So I can see that the whole, I'm going to be a whole at 4. So now I can reset the limit with the new function that has the whole removed, and I can just plug in a 4 and get a 1. Okay. Number 3. Now I can't eyeball this denominator like I could number 1 and number 2. I'm headed to a 1. If I was putting money on this, I would say he's going to have issues at 1. The top, if I plug in a 1, is going to go to 0. But I have no issue with that. Like, that's totally fine. It's the bottom. So right before I do anything, I'm going to plug a 1 into the bottom. So let's see. That would be 1 minus 1 plus 1 minus 1. And that would give me 0. So because of the 0 in the denominator, I cannot take this limit. If I had plugged a 1 into the denominator and gotten like a, I don't know, a 5, then 0 over 5 would have been 0. So the limit as x approaches 1 would have been a 0, free and clear. But because I have a 0 in my denominator, I have to sort of use these other techniques to see if I can find a way around it. So I am going to leave the top alone, and I'm going to factor the denominator. Now, we GCF, piece of cake. Squares, not a problem. Trinomial, no big deal. But when you have 4 terms, factoring sometimes can be an issue. And people call this type of factoring different things. I call it factoring by grouping. And it's only done when you have 4 terms. And I'm literally going to group the first 2 terms together and the second 2 terms together, and that's why it's called grouping. So the first 2 terms, think about a GCF, just for the first 2 terms. So I can take an x squared out. So I'm going to take an x squared out, and then I'm going to write what it would leave me with. First term would leave me with an x. Second term would leave me with a minus 1. Okay, now here's the part that people kind of breeze over really quick, but this is super, super, super important, and it's where a lot of math problems go to die. This middle sign right here is always the sign that comes down right here. And a lot of students glaze over that, and they don't even put a sign right here. But it's really important. And if you go ahead and look ahead to number 4, you can tell that the sign that's going to come down is this negative right here. It makes a huge difference, so be super aware of that. Okay, so second group, what can I take? Well, they don't have anything in common, so I'm going to take a 1 out. Not because I see a 1 here, but because the 2 things have nothing in common, so I can take a 1 out. It doesn't change anything. So it's still going to leave me with x minus 1. Now, when you get to this step, these parentheses should always be the same. If they're not, you've done something wrong. So I'm going to rewrite the top. Then my last step for this kind of factoring is to say, okay, let me look at this plus this and see if those 2 kind of islands have anything in common, like a GCF. And they do. They both have an x minus 1. So I'm going to take an x minus 1 out, and then I'm going to write what that would leave me. Well, if I take them both out, it leaves me with an x squared plus 1. Okay, so just to make sure that we're clear, I haven't done anything with limits so far. All I've done is I plugged in a 1 to see that I can't take the limit, and then everything that you see that's in blue and red is just me factoring. Okay, so now the whole point of factoring was to hopefully get something to cancel, and it does cancel. The x minus 1s are going to cancel. So now I can reset my limit. Don't forget, the whole point of this thing was to be able to pull the trigger on a limit. So I have the limit as x approaches 1 of x squared plus 1. And this is totally fine for me to plug a 1 into. Gives me a 1/2. Okay, number 4. Again, I cannot eyeball this. I don't know if it's a whole or an asymptote, or even if 1 is an issue. So before I go do all this work, let's make sure that we have an issue at 1. And I don't care about the top. I really just care about the bottom. So, and I'm plugging in a -1. Sorry, I didn't see the negative. So I'm plugging in a -1. All right, so -1 cubed is -1. -1 squared is +1 times a positive 4 is a plus 4. Then this is going to be minus a negative 1, so plus 1, and then minus 4. And that, my friends, is a 0. So this guy has issues at negative 1, so we have to address them. So I'm going to factor. Well, unlike number 3, number 4, the numerator has some meat to it as well, and that's 4 terms. So I'm going to be doing grouping on the top and grouping on the bottom. Now please make sure that you remember that grouping took 2 steps. So I'm going to do 2 steps for the top and the bottom. Okay, so for the top, I'm going to group, and circle my middle term, my middle sign. So for the first group, I can take an x squared out. And that leaves me with x plus 2. Then I have my middle sign. And then I can't take anything out of an x and a 2, so I'm going to put a 1 there. But now guys, remember your algebra. If I'm putting a negative 1 out here, then when I GCF that out of these 2 terms, that's going to leave me with a positive x and a positive 2. Taking that negative 1 out, and I didn't decide to take that negative 1 out, I was told, because that middle sign is a negative. So I don't have an option. And then also think about it. If I were to distribute this back through, would I get what I started with? What a lot of people will do, that is a mistake, is they'll see, oh, that's right, she said to put the negative right there, and then, okay, that's going to leave me with an x minus 2. But I hope you can see what's wrong with that. If I multiplied this back through, that would give me a negative x, but that would give me a positive 2. I don't want a positive 2 on a negative 2. So when you GCF that negative 1, it's going to change both those signs. Okay, so that's step number 1 for the top. Now I'm going to do step number 1 for the bottom. So grouping the first 2, I can take an x squared. That would leave me with x plus 4. Middle sign is a negative. Back group doesn't have anything in common. So I'm going to take a 1. But remember, you're not just taking a 1. You have to take that negative also. So that's going to leave me with x plus 4. So that's step number 1 for the top and the bottom. All right, now for the top, for the blue, I can see that they both have an x plus 2. So I'm going to pull the x plus 2 out front, and that's going to leave me with an x squared minus 1. And for the bottom, I can see that they both have an x plus 4, so I'm going to pull it out, and that's going to give me an x squared minus 1. And then as you guys can see, the x minus 1s will cancel. So what I'm left with has a numerator and a denominator. Okay, so but let's remember our limit. Remember, the whole point of this is to take the limit. So as x approaches negative 1 of x plus 2 over x plus 4, well, this function still has issues. Where are his issues? Look at that denominator. His issues are at negative 4. Where are we headed? We're headed to a negative 1. So I'm not interested in the fact that he has issues at negative 4, and that would be an asymptote, not a whole. So he has big issues at a negative 4, but I'm headed to negative 1, so I can just plug this in. So I know that the limit as x approaches negative 1 of this beast of an equation is headed towards a 1/3. Okay, so 1 through 4 was all factoring and trying to get the issue to cancel out. And when that cancels, remember that's a hole. So the limit still exists. So once I get that hole out of there, I can reset my limit and try it again with my new function. Number 1, we did a trinomial, 2 trinomial, and then 3 and 4, we did grouping. But remember, GCF is part of your factoring, and so is the difference of 2 squares. So just remember that that's all on the table as far as something that you could use. Okay, number 5. Well, this has a root, and it has a denominator. So first of all, let's look at where we're headed. I'm headed to 0. So I don't really care about the top. I'm going to focus on the bottom. Can this function exist when x is 0? And the answer is no. And number 6 is the exact same thing. I can't head to a 0 because that would make the denominator 0. So I have to come up with some way to fix it. Factoring is not going to work with this. I can't factor the square root of x plus 1 minus 1. There's no GCF, they're not squares, it's not a trinomial, and I don't have 4 terms. I can't do the grouping, which we did in number 3 and number 4. So what I'm going to do is I'm going to multiply top and bottom, because that's what keeps it legal, by the conjugate of the top. Normally, we multiply by the conjugate of the denominator because there's something down there that we can't have down there. But for this one, just to give it a little bit more meat and see what we can kind of make cancel, I'm going to multiply by the conjugate of the top. So root x plus 1 plus 1 over root x plus 1 plus 1. So notice I did not change the sign of the thing inside the root. I changed the sign in between the 2 major terms. Okay, so the top. Now guys, the top, they are conjugates, so there is stuff that's going to cancel. But I need to know what root x plus 1 times root x plus 1 is. So remember, way back in the day, we talked about root 5 times root 5, which is root 25, which is 5. And we said, okay, root something times root something is just the something. I even said root a cow times root a cow is just a cow. So if I had root star times root star, the answer is just a star, because this would give you root star squared, and the root and the square would cancel out. So if I have root x plus 1 times root x plus 1, that's just going to give me x plus 1. Okay. Then I have this and I have this, which are the same thing, but one positive and one negative. So because they're conjugates, they're going to cancel. So now I have to do this, which gives me minus 1 over. Okay. Now, I've done enough of these to know the pattern. You are going to do enough of these to see the pattern, but let me tell you, on the denominator, do not distribute that x. Keep it. Do y'all see what I mean by don't distribute the x? Keep it out front, because look a couple steps down the road. What's going to happen to the top? Well, the ones are going to cancel, and I'm going to have this single x sitting on top. And now I have the single x on the denominator, so then they are going to be able to cancel. And then I'll be able to reset my limit. So the positive 1 and the negative 1 cancel each other out. So I have now a single x and then a single x and times the square root of x plus 1 plus 1. So these can now cancel. Guys, that's that whole at 0. So now I'm going to reset my limit. Again, remember, because I'll have some students who will do this and box in their answer. But you never took a limit. So that is my new function, but the whole point of this was to take a limit. So now I'm going to do the limit as x approaches 0 of my new function. And I'm going to plug a 0 in, and 0 plus 1 is 1, and the square root of 1 is 1, and 1 plus 1 is 2. So again, 1 through 4 we factored and canceled. 5 and 6 we can't cancel, so it's called rationalizing. We're multiplying by the conjugate, and the weird part is it's the conjugate of the numerator. Okay, so number 6 is the same thing. So I'm going to give you about a 30-second head start. I want you to multiply by the conjugate of the top. So the sign that you're going to change is that one right there. So top and bottom, conjugate of the top. Okay, so if I do 1 times 1, I get a 1. Then 1 times this, I get a 1 root 1 minus x. Negative root 1 minus x times 1, I get a negative 1 root 1 minus x. They're going to cancel because they're conjugates. Now this you have to be super careful. So if you've kind of worked ahead, stop and make sure that you understand this. This is the whole root of cow times root of cow. So I'm going to get a cow. But in front of that, I have a negative. And that negative has got to run through what's coming out from under your root. So technically what you have is a negative 1 minus x over x. Don't distribute it. So take just a second and make sure you understand what I just did. The bottom is just the two pieces multiplied together. Remember we said we were not going to distribute that because hopefully he's going to cancel with somebody. But make sure you understand here on the top, I did 1 times 1, I got my 1. Then this times this and this times this are going to cancel. Positive and negative of each other, they're going to cancel. And then when I do this times this, there's my cow. There's my 1 minus x. But this negative is from this negative times this positive. And this negative has got to run through. So this is really 1 minus 1 plus x. And guys, I can't count how many times people lose that sign right there. Because they just say, oh, it's a negative, and then it's the cow, the 1 minus x, but they don't run that negative through it. So here's your warning. Be careful. All right, 1 minus 1, those are going to cancel on the top. And then this single x and this single x, they can cancel. Okay, but remember, we haven't taken a limit yet. The whole point is to take a limit. So I have the limit as x approaches, I think we were headed to 0. Yep. Of my new function, 1 over 1 plus the square root of 1 minus x. And now I can plug in a 0. Well, 1 minus 0 is 1, and the square root of 1 is 1, and 1 plus 1 is 2, so 1/2. And before you get real excited and say, oh, well, the answers to these must always be a 1/2. Well, they're not. Let's look at number 7. Okay, again, I'm headed to 0, and that's bad because I have an x on the bottom, so that would make my denominator 0. I'm going to multiply by the conjugate. Okay, so I'm going to be quiet, give you about 20-30 seconds. Dive on in, see what happens. So root x plus 25 times root x plus 25 is x plus 25. Root of cow times root of cow is just a cow. Then that's going to be a positive 5 root x plus 25. And that's a negative 5 root x plus 25, so they cancel. And then that is a minus 25. And right here I get a lot of minus 5s. But remember, those are not under the root. That's just good old 5 times 5. Then the bottom, I'm going to leave that single x out front. I am not going to distribute him. The 25s cancel. Then this single x, because the 25s are now gone, and that single x can cancel. I will then reset my limit I will plug in a 0. 0 plus 25 is 25. The square root of 25 is 5. And 5 plus 5 is 10. So 1/10. Okay, so that's it for rationalizing the denominator. So again, to recap so far, we factored and canceled, and we multiplied by the conjugate. So now let's look at number 8. So number 8 and number 9 are trigs. Of course, whatever we do, we have to always finish by doing the exact same topic with trig. Now I'm headed to pi. Well, let's see if he has an issue at pi. Sine and cosine are very well-behaved functions. They don't have any asymptotes, not like tangent and cotangent. So I'm just going to plug in a pi and see what happens. It's almost like don't create a problem until you know there is a problem. So if I go 1 plus cosine of pi over sine of pi. Okay, now I'm going to slow down just a little bit because we're going to reference back to the unit circle. Okay, so let's think about where pi is. And the ordered pair for that would be -1, 0. I really don't care about the top. I'm only going to have issues if the denominator goes to 0. Well, sine of pi, sine is the y value, and so sine of pi would be 0. So that puts a 0 in my denominator, which is not good. Okay, so I cannot just direct substitution. I have to figure out some way to make this okay. Some of you may look at this and say, oh, well, back when we did trig, we could pull it apart. Okay, so don't write this, but just watch. If I were to pull it apart, and I can pull it apart because there's only one term on the bottom. So this would be cosecant, and this would be cotangent. And we're headed to pi. So cotangent of pi. Cotangent, do you remember where his asymptotes are? Cotangent, his asymptotes are at 0, pi, and 2 pi. So is this okay? No, because cotangent has an asymptote at pi. I cannot cotangent a pi. So pulling it apart does no good. Okay, back to the drawing board. This limit is sort of set up like number 7. I mean, he doesn't have a root, but it's very simple. I've already decided I can't pull it apart. So what I'm going to do is I'm going to go in and multiply by its conjugate of the top. Top and bottom, that's what makes it legal, because you're just multiplying by a big fat 1. So now if I lobster the top, I'm going to have 1, then a minus cosine and a plus cosine, they're going to cancel, and then a minus cosine squared x, that should make you think of something. Then the bottom, again, I'm not going to distribute. I'm going to kind of hold that sign out for a second. Okay, now think about your trig. What was 1 minus cosine squared? Anytime we saw 1 and something squared. So it was sine squared plus cosine squared equals 1. That was that first Pythagorean. So 1 minus cosine squared is sine squared. Now if I replace that, and y'all can see now why that trig chapter was so important. If I replace that now with sine squared, can I clean it? Can I cancel? And yeah, cancel that little guy with one of them. So now I'm going to reset my limit. Okay. Well, now let's plug in. Let's see if what we got. Let's see if it's okay. So this is going to be sine of pi and 1 minus cosine of pi. All right, back here was my pi. Here's the point I'm using. I'm really interested in the denominator. So cosine of pi is a -1. Now be careful with your signs here. It's not 1 minus 1. It's 1 minus a -1. So I have a 2 on the bottom. Then sine of pi is going to be 0. And 0 over 2 is 0. But guys, that's a legit 0. Like, that's not a 0 on the bottom and it's undefined and that makes us uncomfortable, so we just put a 0. This is a legit 0, 0 over 2. So make sure you understand the difference between that and something that's undefined when you have 0 on the bottom. Okay, last one. So we are headed to pi over 2. Okay, so let's check out sine of pi over 2. Let's see if we have issues. I really only care about the denominator to see if I have issues. So let's see, pi over 2 is due north, and that is 0, 1. Tangent is y over x. That's bad, because that's going to give me 1 over 0, which is undefined. So tangent is undefined at pi over 2. And if I remembered my asymptote rules, I would remember that tangent is undefined at negative pi over 2, and 3 pi over 2. So bad. Very, very, very bad. Okay. So let's think about this. I could... let's go sine, because I can't really go conjugate because it's one term over one term. But what if I go sines and cosines? And then a little same change flip. Oh, looky there. The sines cancel, and I just have cosine. Okay, so now let's reset my limit as x approaches pi over 2 of what was left, which is cosine. Cosine of pi over 2, cosine is the x value. There you go. So don't be afraid of 0 as an answer. Be afraid of 0 in your denominator. 0 in your denominator means back up, try another avenue. But just a plain 0, 0 on the top, it's no big deal. You can have a limit that approaches 0. Okay, so I hope this was helpful. I hope that you can pause and rewind and go back and watch whatever you need to let it soak in enough to where you feel good to go. All right, and just send me any questions that you have.